TIES, or the Technological Innovation and Entrepreneurship Space, is located in the south side of computer science. We're entering through the east door here, and it is a card swipe. But all students in the School of Engineering do have 24/7 access, swipe access into the building. As you enter here, we have a conference room over here. Student groups can get together, have meetings there. We do have some classes that occasionally meet in there as well. Moving down the hall, this is one of the main labs of the TIE space. So coming into the lab here. So in this TIE space, there are a lot of hands-on tools. We have, well, let's just work our way around the room here, and we'll start from the left. We do have some basic electronics prototyping, resistors, capacitors. I think there might be an Arduino or maybe a Raspberry Pi up there. Standard, traditional mold making. We can cast and mold various materials. Most of them are silicon-based, RTVC materials, and so forth. Then we've got some, general sculpting and so forth. So there, your kind of traditional model making and mold making and so forth. This is injection molding here. So this is an injection molding machine, very small scale, hand operated one there. It largely demonstrates the idea of injection molding. We do have a few molds that have been made up here. This, for example, is a mold that we'll just make these little beads, basically. This was a student that took it upon themselves to learn how to do machining for mold making, made those molds, and then we produced some beads with those. I think I've got another example here. That's a fishing lure, and then it makes these little guys here like so. It's really efficient if you're making hundreds or thousands of a particular model, but the time involved in making just one of those molds was hours and hours in design, hours and hours in machining in the metal to get something that would actually produce a part for us. So anyways, we have it, it's available, it's a curiosity, and students can use that as they need to. Adhesives and tapes and so forth. We've got a couple of different 3D printers in here. So we have our FDM printer over here. There's a couple of other printers down the hall. We'll show you those in a second. This is an SLA printer, a high resolution printer that works with a liquid resin, uses a UV light laser beam underneath there to shine and cure that. These are examples of parts that were printed with that. You can get much finer detail and create some structures that you can't do necessarily with FDM printing. This is part of a skull. I think it was part of a 3D scan of a saber-toothed cat skull. It was 3D printed on there. And some examples of some these are chairs that were used in a model for a BIM project, Building Information Modeling project. The students made small models of the houses that they were constructing. And this is a piece of the Eiffel Tower just to demonstrate the level of resolution and precision that printer can do. So very high detail, high precision, but not very large. You get about 5 inches on a side with that one. But something that jewelers and dentists and so forth could use. You've got less than 0.1 millimeter resolution, I think, on that guy. The FDM printer is more your traditional fused deposition modeling printer. Basically, it's like a hot glue gun on a robotic gantry. It's going to squirt out this liquid plastic that cools and hardens, and we build up models layer by layer. These are a couple of additional 3D printer heads that work with that. We can print in different types of materials. We can print with 2 materials at once, and we can use dissolvable supports and so forth. Moving around this way. This is our laser cutter and engraver. It's a 60-watt CO2 laser, has a roughly 14 by 16 inch bed on it. I put the parts on there, the laser head moves back and forth, the laser tube is in the back there. We can cut most materials, you can see on the chart up here, essentially acrylic, wood, paper-based materials. We can do some etching on glass and like stone type materials, like granite and so forth, ceramics and so forth. It'll only etch, won't actually cut those. It does almost nothing to any metals. the power and the wavelength of a CO2 laser just isn't conducive to cutting on metals. Down here on the floor is a vacuum molding machine. You can create a shape or form, heat up a sheet of plastic till it's soft and pliable, and then pull that down over a shape that you have laying on the bed down there. We have all kinds of various hand tools and so forth, screwdrivers, wrenches, hammers, you name it, a variety of miscellaneous screws and so forth. It's kind of like, have a penny, leave a penny. I do the same thing with screws, so if you need a couple of screws, feel free to dig through there, find something that you need. If you've got a few leftover screws, you had to order a pack of 25 or something, gratefully take those as donations to add to the same thing. Up here we just have examples of some various projects that students have done over the years. That's an example of a BIM model up there. There's a tiny house that they had to build. Some decorative coasters and so forth, some signs that we've done and etched and cut those on the laser, and different ways of taking three-dimensional shapes and cutting those into components and then reassembling those. And then we've got other various hand tools over here. Your powered saws, staplers, drills, and so forth. So now if we move over into the next room over here, we have our slightly dusty, dirtier, and more dangerous tools on this side. So as we enter into this room, we have more machine technology tools in here. Starting on the left here, we've got a vertical bandsaw, great for wood and plastics use. In the shop next door, we do have a vertical bandsaw and a horizontal bandsaw for metal cutting. We've got a disc and belt sander combination here on the bench, a small miter chop saw there, all kinds of clamps and so forth for gluing up and putting projects together. That's our dust collection system in the corner there. That's tied to our CNC router, plus some of the other tools that we're using over there. They can be connected to any tools that we may be using on the workbench over here as well. The CNC router, it's a 4-foot by 4-foot Laguna CNC. We use Vectric VCarve software for producing the tool paths for that. Capable of cutting woods, plastics, some aluminum, up to maybe a 1/4 of an inch thick aluminum. Wood can be cut to whatever depth that you've got the tool bit for, an inch or so. It does have a 4th axis rotary on there. That's where we produce some of those spiral objects and stuff up there on the shelf. And so moving over this way, we have a drill press on this side. Workbench in the middle here where students can assemble projects. I have a small bench style hobby metal cutting lathe on this corner here, and associated tools that go with that. And then we do have a chemical safety hood, but we use it mostly as a paint booth, or anytime you're handling any chemicals or solvents or anything like that that may produce a hazardous vapor. We can work inside the hood there. And last but not least, in the corner over here, we have a small scale CNC machine capable of machining roughly 8 inches by 8 inches by about 3 inches depth. Can cut soft metals like aluminum and brass, and work in plastics, acrylics, and polycarbonates, and so forth. A fun little tool to practice on before moving up to a large machine like the Haas CNC or something. Okay, if we move out of the shop and back out into the hallway here, we have my office directly in front of us. Over here is the Geotech lab with Dr. Mary. And then we have this room over here, which is typically available to students. Those doors normally unlocked and open. We've got 4 PCs in here. You've got your SolidWorks and so forth. Computers are set up more or less like they are over in Anderson. We also have 2 3D printers that are available down here. They do require a prior reservation, or at least informing myself if you're going to be doing some printing in there, and then coordinating getting you some filament or using the right types of filament. And I'll do a training with anybody that needs to learn how to use those. I also have a YouTube video that I can point you to that to get you started on doing that. We have a sewing machine in here as well. Some projects require putting together a belt or maybe a soft-sided battery pack or something. So we have that tool available as well. Like I said, this room is available for students to study in and work on. Vinyl cutting machine, which I keep the supplies in the lab, but again, you're welcome to use that. We can do stickers and logos and so forth with that as well. Some of the stuff in the corner there is on its way to being salvaged and put away, so we'll have more desk space available for students to use down there. And then lastly, if we move down the hall, moving west through the building, this is the other entrance, and oftentimes when I print objects for students and leave them, they can come by and pick them up here on this counter. You guys keep different hours than I do. And then lastly, we have one of many student projects that are on display around this space here. This is an augmented reality sandbox. And just like the conference room when we first came in, this space is available for small groups of students to get together to work on projects and so forth. A couple of other projects we've had up here, some posters, like to present those. And